Hey everybody, this is Larry, this is me going Q4 of the weekly contest 296, Design a Text Editor. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this poem. Before going into this poem, I want to talk a little bit about, so this was my worst problem in the contest. I mean, it's a Q4, so maybe not unexpected, but I think for me, like I was saying in my other video, one of my sticking point lately has been implementation. In terms that I know what the algo is, but I've been a little bit either reluctant or lazy maybe in implementing it because I think, oh, maybe there's an easier way. And sometimes there maybe not, right? Maybe you just have to grind it out. Maybe, my code is, let's see. My code is actually not that long, 65 lines of code, but I was thinking that maybe it's it wasn't even the implementation with respect to that. It's just that I worry that the way that I was going for had too many edge cases, and therefore I'm going to eat a lot of silly mistakes. And as it turns out, I did have a 5-minute penalty, which probably was very costly for this problem because a lot of people have solved it very quickly. Yeah, but that's basically my thing. And I think one thing that for me I have to do a little bit better job of is just going hard and going fast. Sometimes maybe it is just my first thought, because if you watch, and you can stay and watch how I solved this live, I kind of wasted like 3-4 minutes. I wasted 3-4 minutes just looking for a different solution. And for me, for this problem, I think there are actually a couple of possible solutions. But they all have the same idea, just different implementations. So all the solutions are the same-ish. There are different implementations. I'm gonna go over one, the one that deals with these constraints, and then I'm gonna challenge you to upsolve at least your implementation at the end, or not at the end of the video, but a little bit later on. So stay tuned for that, with some hints, if you will. But yeah. Yeah, so I think the one thing that you have to think about with all these classes is just think about what is the most costly part of it, right? And I think that is probably the trickiest part. Like in a way, some functions can be more expensive if other functions are cheaper and so forth, and it depends on how the constraints go. So one of the earlier things that I did is look at the constraints. I also had some silly typos, but that's besides the point. First thing I noticed is that k is less than 40, so that means that I can be kind of sloppier in how I want to do it with respect to time complexity. So that's basically what I did, is that I kind of, yeah, I mean, adding you can really do faster, because in the sense that you need to process each character anyway. So yeah, so the way that I did is O of 1 per character or per k, but we'll talk about it in a little bit. The key idea for this part, the way that I solve it, is using a doubly linked list. Why did I come to that? It's basically because you have to go left and the right. Probably that's double linked list, but more importantly, you also need to insert and delete from the middle, right? And because you have to insert and delete from the middle, you think about using an array, things are going to get empty, you have to compress. Maybe you could do some math with memory, what's it called, garbage collection type stuff. But using a doubly linked list is the way to go, because you can go left and right. And hopefully, if you haven't solved it yet and you're watching this video, some people also have solved it and kind of see if Larry has different code. But yeah, but I hope that with this hint that you can, make an attempt, right? Because I think doubly linked lists is something that comes up in a fundamental way. But for me, it is one of my weaker points, because to be frank, on competitive programming, it doesn't really come up that much. Maybe on interviews, but even then, not really that much. So it's not something that, it's something that I think about, but it's not one of the first 20 things that I think about, right? And as a result, one thing that I was thinking about doing was using sorted lists or some kind of, tree-ish data structure, or like a segment tree or something, right? But yeah, that's basically the idea here. And I'm just gonna go over the code. It's pretty straightforward as we saw, because now you initiate, you just have a head node and also the pointer to the end. And one thing that I would say, just to be clear, I think it's very easy to have off by ones in these things, even with doubly linked lists or nodes and stuff like this in general. The way that I have it in my mind, just to be clear, is that the cursor, which is the self.current, represents, it points at the last character that, or the first character that's before the cursor. So I had that invariant in my mind, so that later on, and it's very important because it's very easy to both make a silly mistake, but then also you have to, if you do make a silly mistake, you have to be able to recover from it and debug it and fix it and so forth. Yeah, so that was my idea in my head that allowed me the invariant that made sure that so that every function can be based off that invariant, and every function just has to make sure that that invariant holds after it runs, right? Yeah, so that's the idea. So now I also have an empty head node, so that it makes some math easier, as you'll see later, or implementation a little bit easier. So I did get a wrong answer on this one, which is very sad, especially for this problem. The idea behind so what I got wrong was that I forgot to, that because I was in my mind initially, I was just looking at the examples, and in the example they always add to the end, so I just kind of forgot. I knew that I was thinking about it in the beginning, but then I honestly just forgot about it when I got to implementation. So I didn't have this chunk, and what that means is that I could not insert in the middle. I just kind of keep on inserting to the right, so it would just delete stuff. You know, so that was a 35-minute mistake. Delete. So yeah, so here we just keep on adding things in the middle, and then just add things to the old stuff to the end. And these are like very standard double linked list stuff, so I'm not gonna go over it too deeply. The way that I say, if you do have issues debugging, draw out small examples and draw where all the pointers are, and making sure that all the new pointers are pointing at the right things. I didn't necessarily do that because I've done enough of these problems, but that said, I'm also the one that got it wrong. So you know, maybe you should listen to what I wish I did instead of what I actually did, right? Yeah. Anyway, yeah, delete text is the same thing, right? So given the current cursor, I just, and one thing that I do is that I make sure that if C is none, it means that I'm at the head node. That was my other thing that I didn't really talk about in terms of invariant. But yeah, so if this was already the head node, then we don't delete. Otherwise, we delete one character. And then this is just standard doubly linked list deletion, right? You set the previous next to good, and then your previous to next, and so forth. You can also set the current, or you can also additionally set the current node to none. But yeah, and then here, I think that's where the invariant helps me, is that now I'm trying to think where the cursor should be. Well, it should be on the previous, because the invariant that we talked about. The cursor left is even, is by that idea straightforward. You move the cursor to the left X or K times, making sure that we can go to the previous, because otherwise you have the head node, and that's not Gucci. Yeah. And then here we just look at the last 10 characters. So this is O of 10. So yeah, I mean, this is what you needed. I kind of should maybe implement this a little bit better, but nonetheless. Yeah, same idea to going to the right, doubly linked list, go to the next, right? That's pretty much it. And then we have to look at the last 10 characters as well. Cool. So that's pretty much it. As I said, there is a sorted list solution, which you can kind of do with tricky math with insertions, but it should be okay. I mean, there are ways you can do it. It's not that bad. It's not impossible. So one idea that I challenge you is that, okay, K is 40, text length is 40 as well. So that is why I'm able to kind of walk the linked list, right? Otherwise it will get expensive. So my challenge to you, for the viewers at home, is what happens if K is unbound? Meaning that K can be any number. If K can be any number, how would you solve it? I'm going to tell you. So pause the video if you're trying to work it out or whatever. there are a couple of solutions as well. So there's the hint that I'm going to give is probably not the only way to solve it, but do try to give it an attempt. I don't know if it's easy, to be honest. Maybe it's even very hard, especially or it's very hard in the sense that if you haven't done it before, maybe it's even just very tricky, very impossible. But give it a try, see how far you can get, and explore the ideas that you're doing with, right? Oh, sorry. Let me also just show the code like one last time so that you can see it at home. Right? So it's not that bad, but and in fact, a lot of people got it. That's why my ranking is a little bit bad today. But yeah, so if k can be any number, how would you solve it? Pause, and then now here's how you would solve it. So you can do a couple of techniques. Most of these are kind of playing with the idea of, just the similar idea with, what's it called? There's a fancy name for it, but I didn't remember this way. But the one idea that you can do is similar to kind of how you solve RMQ, right? Where you can have, I'm blanking out the name, sparse table. I think that's the name that people use these days. So I think sparse table is the name now that I think about it. So you could definitely use sparse table type thing to kind of figure it out. Not the same idea because of this, but also, but yeah. And then the other thing is this idea of not necessarily a sparse array, but just, that idea of having higher level nodes where you only have some of the nodes, right? And then now in that case, of course, I was going to say that the reason why I don't remember sparse table by that name is that I actually learned this sparse table technique by reading the original RMQ paper. And that paper, I think this is before the term sparse table is a thing. So yeah, so I have to remember that that's the name of it. But anyway, so the other data structure that you can play around with is, and if you're not familiar with this, you're not familiar with this, and I recommend you Google this. It's called a skip list. But of course, there's also other data structure that's similar to skip list, like a tree or some sort of things that does it. And of course, both of these things have a randomized component, but on average, it should be okay, especially if you're given enough things. And this is just my hint and how you can use K to do it. I'm not going to do any proof or anything, but you're able to kind of skip ahead to okay, skip this. Whoops, no pun intended, but I guess I made it anyway. But you kind of use the idea of skip list to implement how to move K very quickly. So that's basically the thing. Cool. That's all I have with this one. Let me know what you think. Let me know how you did. Let me know if you're one of the many people who could beat me, because I was very slow on this one. And leave a comment below. Anyway, you could watch me solve it live in a contest now. Hopefully this is right. Okay. Oh, this already looks annoying. Move the cursor left or right. Okay. Oh, just the last 10 characters. This seems like a linked list problem, to be honest. Am I doing on time? I guess just loading. Contest has ended. That seems unlikely, but okay, either way. I think my thingy is loading, so that's not good. Okay, there we go. I'm spending too much time on this, but okay. Okay, so I could also use sorted list maybe. Can I? Delete text. I am trying to think whether I should use. I think sorted list is fine, actually. Yeah. Okay, add text. I guess maybe not. No, let's just use the node. And now self.current dot next is equal to node of C maybe. Self.current is equal to self.current dot next. Okay. Real quick. I should have done it. I probably spent too much time thinking about this one. Overcomplicated a little bit. Okay, delete text. Backspace, right? So then now. So current should be at the node that is right after. So okay. So then now this is current. The previous is. So I messed up here. Equals self.current.next.previous is equal to self.current. Should have an add node function, I think, but this might come back to haunt me. We'll see. It's easy to mess this up. Okay, previous yourself.previous, and now previous.next is equal to self.current.next, and then next.previous is equal to self.current.previous. Oops. And then now self.current is equal to previous, and that should be okay. And what do we return? What are we returning? Okay. I actually didn't do that because I just did it in one character, right? So for to in range of okay. So we have to check. So if self.current.c is none, then we already reached the beginning. So we continue. Otherwise, I mean it's continue, but I think I should break actually. None type no previous. That's probably true because none type of no previous. Self.current.previous. What? and then delete 4. Right. Okay, that's kind of what I expected, which is kind of bad, but and also assert that. Why would things should always have a previous, right? Oh, because the head doesn't have a previous. Huh? Damage to current is none though, right? What are we doing? Okay. So it deletes the ye, which is already maybe wrong. Oh man, I am really bad today. Because this is pretty standard, I think. Leetcode. Oh, that ye. Okay, no, actually that ye is right. I was looking at the lead for some reason. Okay. Why is self.current dot previous? That looks like a node. I messed up. 1, 2. Oh, it's this one. Because self.current is changed. What am I doing? I think the previous .next or something changed it, but I don't get it. Huh. It's previous none. Oh, the next is not none, that's why. Oh man, I've been misreading. I've been misreading this entire time. Ah, yikes. Okay. Is that right so far? I don't know. My cursor left. I imagine people are already done with this because I spent too much time. Oh, but you have to return. What does this thing do? Right? So last to the left. Okay, so cursor right. Okay, so then, so cursor left. We want to see what? Also to the left. To the left of the cursor. Okay. Because otherwise you're at the head, and then now to look at the left. Okay, so then now was it 10? Oh, 10 or the main length. Okay, fine, that's fine. Yes, okay. So teal, is that right? They don't tell you the other one is lead, so I'm very, very wrong. Oh, because I didn't move right, so maybe I have to do this one first. Okay, fine. Imagine a lot of people are done by now, to be honest, but that's fine. Okay, this is still wrong though. Okay, so we want this to be the answer. What am I doing wrong? Leetcode. Did I misunderstood the problem? Let's see. Oh, I'm doing it backwards, am I? And also, am I supposed to the left of the cursor? Is it the stuff that we already processed? Maybe I misread this one, that's all. Okay. So the cursor is here, move to the right, and then it goes to the last 10. Okay. So the cursor right should be fine. Oh no, cursor right is to the left. Did I miss? Oh, this part. Oh yeah, okay. I mentally copy and paste and then changed it, and then I didn't fix that we want the left, so this is still previous, even though this is on the right. Okay. Still not very right though. Don't even know what that is. Well, we do add it backwards, so lead practice. Okay, cursor to the right. So I think this is just up backwards, that's all. I think I was thinking about that while writing, but forgot. Oh jeez. Pay to win. Okay, so yeah, practice and practice. Okay, this looks good. Let's give it YOLO submit. Hopefully no TLE. With TLEs, okay. Wrong answer is actually a little bit sadder because I actually was wondering if it was going to TLE, but that's, I think people already gotten this though. So yeah, I don't think this is that bad, but I should have gotten this. We'll probably have a mistake somewhere. Okay, what is this going on? So 12. 1, 2, 3. Oh, do I add wrong? I think I add wrong. I do add wrong, cause I assume we add in the end, but that's not true. We have to insert, right? So then now, okay. Oh, next. I made such a mistake here. Okay. Yeah. Okay. And then now, old next self.current dot next is equal to old next, and then old next dot previous or prev is equal to self.current. Oh, that's such a yikes. Actually, I was thinking about this case when I was writing it, but I forgot. Again, if old next is not none. Good thing that that's a thing though. I'm just being sloppy here. Okay. So this looks okay, so let's go. Run it one more time. Oh, jeez. Come on. I'm trying again in a lot of seconds. Okay, fine. Okay, this looks good, this looks good. Let's give it submit. Hopefully no more silly mistakes. Wouldn't be surprised if there were, but okay, cool. I should have gotten that earlier though. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, these problems. Kinda did okay, but yeah. I'll see you later. Take care and goodbye.